Alrighty, so we have here a couple of examples of questions involving nuclear decay in a medical context. Okay, this is all about traces. So this isn't about gamma radiation, this is about tracing or diagnosing. So these are both radioactive things that are being placed into the body, intentionally decaying. The trick to these problems is pretty much the same as the trick to most problems in physics. If you don't have any idea, this is a really good strategy to follow. Write down what you know. Look for an equation that suits that, rearrange to find your unknown. So what do I know? James?
Half-life.
Half-life. So I'm going to represent with H. H equals what? Minutes is probably also a good thing to throw down. 5 minutes. Yep.
Go the N.
N is what?
5. 0.05.
Yep, so my final amount is 0.05 and my initial amount is? Thanks, boys. Shh. I'm going to write that up here, actually. So, what am I looking for then? T. I want to know what my time is. So write down my equation. My equation is N equals NO half to the power of T over H. I sub in my known variables. So my known variables in blue are 0.05 equals 5 T over 5. I now rearrange using reverse BOMDAS. Reverse BOMDAS says I should get rid of which operation first, Bevan?
Division.
Have I got a division here?
You divide by 5.
I want to get rid of the multiplication, so to get rid of the multiplication, I divide both sides by 5. Because I'm using reverse BOMDAS. I then solve, so I get 0.01 equals half to the power of T over 5. What's the problem here?
There is no.
Unknown is in the power or the indice. So to get to my indice, I need to apply a log. So I log both sides. Now there's a special rule that we apply here. What's the special rule? The Plog law. And that just means I can put my power, or I can plonk my power out the front. So that gives me T over 5 times log of a half.
Just get through this.
Divide both sides by what?
One half.
Log half. They cancel. Log 0.01 over log half is what? What is it?
Well, that equals 6.6.
6.66 times by 5 equals T. T equals 30, what was it? 32, 33.3. Clear? Approached with the same strategy here. The only thing that is different is you might need to identify N or NO before you actually start with the 60 and the 30%. If you're very confident, you wouldn't even need to find out the mass. You just need to know that you want between 60 and 30%. So the way that I would solve this is I would let N equal 30%, NO equals 60%. It doesn't matter how much. It's a half-life decay. It doesn't matter how much mass I have. What matters is the percentage that I have. I can already tell you the value. If you're switched on, you'd see how that works. Do I need to even calculate anything?
No.
Why not? What's half of 60? What happens after a half-life? Half the material decays. So my half-life is 6. Guess what my time is going to be?
3.
They have a 6-minute window.
Yeah, a 6-minute window to get the operation, to get the scan done. If you did it with the mass, or you treated it as 2 equations,
We wasted time.
you didn't. How? Why would it be important to do the equation here, not just guess? What if I made this number 25? Then you'd have to do the equations, correct? It was only because it happened to be the half that you could save time. If I asked you instead, how long do the doctors have? If I asked you or at what point should they start scanning, or when's the first time and the last time they can start scanning, then you'd have to take the approach of finding out how long it takes to get from 100% to 60%, and then find out how long it takes to go from 100 to 30%. Cool? So I can ask a whole range of different questions here. My advice to you is stick to that philosophy. Write down what you know, identify the variable you want, rearrange for your unknown. Be comfortable finding any unknown. If you can't get to any unknown, then you're putting yourself in a bad spot. Cool?